Okay, let's continue. Okay. Okay, student, you might also use ozone. Okay, you might also use ozone for treatment. Okay, so because we know the ozone is a very strong oxidizing agent. Okay, ozone is very strong oxidizing agent. It can be combined with hydrogen peroxides, UV lights, even react with ultrasonics. Okay, and these combinations will produce very strong oxidation reactions. Okay, this combination will produce very strong oxidation reactions. Okay, this combination will combine as a strong oxidation reactions. So we can use that to treat some difficult organic pollutants. Some organic pollutants. Okay, such as some chlorinates, solvent, PCBs, all these two. So 1,1 DCA and 1,1 TCA. We can use ozone to remove those difficult, tough organic pollutants. 1,1 DCA, 1,1 BCA, or some PCBs. I would like to change tree to destroy. Okay? We use ozone as a strong oxidizing agent. And ozone can combine with hydrogen peroxide, UV, become a very strong oxidation. So use that to destroy. Some tough organic pollutants, such as 1,1 DCA, 1,1 DCA, PCBs, or some chlorinated phenyls. All right? So next slide, I would like to talk about air strippings. Air stripping is good for the removal of volatile contaminants from water and soil. Okay, and this is from textbook. Okay, so air strippings. So the ZR, the ZR stands for the peg tower dips. Okay, you can calculate peg tower dips, okay, using the equation, using the formula 14.4 from the textbook. Okay, this is design equations. Understand? So let's see example 14.3. Example 14.3. So these questions, okay, student, take a look. This question asks you, I might ask this kind of question. Student, I might ask this kind of question in the final. I will repeat very many times. Okay? I will not ask you to derive this, but I want you to know how to apply the formula. Okay? So this question asks you to design the peg tower stripping column, which means let ask you to find out ZR. To find out ZR. Okay? To find out ZR. Okay, and this for this example. And this water contains 35 microgram per liters of 1122 tetrachloroaxane. Let me ask the organic expert. 在玩手机那一位，收到券 ，please come to the bravo. Please come here. Okay? 可以吗？画一下1122 tetrachloroaxane。会画吗 ？Can you draw 1122 tetrachloroaxane? 1122。来那个 class rep, please come to the bravo. 你在干嘛？ Who know how to draw 1122 tetrachloroaxane? Please raise your hand. 你准备吗？可以吗？怎么画？
先把主编换出来，然后
两个 C， 然后呢？没有，我说画这个的。
对啊。主编画出来，然后在一号位置画2个绿，还有2号位置画。
这边2个绿，然后这边
也是绿。
Student, 1122 chloro tetra. Tetra means 4. 4 chloro. 1122 chloroaxane. Okay? And water must be cleaned to detection limit, 1 microgram per liters. And the question asks you, okay, to design. So that means you want to change from 350 to 1. Okay? You want to reduce the concentration from 350 to 1. And ask you to design a peg tower stripping column. Okay? Understand? So, just simply use the formula. Just simply use the formula. We can find out. The answer will be 29.69. 29.69. Okay, so student, take a look. By changing the diameters, you can change the tower height. by changing the diameter, you can change your tower height. If you don't want your tower too tall, you can enlarge the diameter. Okay, you can enlarge your diameter. Okay? So the next few slides show you the airstream tower, okay, in real case like this. Okay, if you don't want it too high, for example, like you don't want it to above 5, okay, you can increase the diameter. Okay, so this few slides showed you the power, the airstream tower. Okay, so Henry's law come again. Okay, Henry's law come again because there are some amount of the gas. Okay, there are some amount of gas will dissolve in water. Depends on the gas pressure, right? The amount of gas dissolved in water depends on the gas partial pressure above the water. So the Henry's law is something you need to memorize. Okay, the Ca, the concentration of A, concentration of the gas dissolved. The A means the gas dissolving water. The concentration of gas dissolving water equal KH. The KH is Henry's law constant. Okay? Times the partial pressure of gas dissolving water. Okay? Okay, this slide shows you the ideal gas law. Okay, the relation between the ideal gas law and Henry's law. Okay, let's see this example. The solubility of oxygen in water. Okay, so the air contains about 29% of oxygen. So PO2 is about 0.209 atm. Okay, if PATM equals 1 atm, P air equals 1 atm. Let's assume P air equals 1 atm. If the total air pressure is 1 atm, then the partial pressure of oxygen in air will be 0.209 atm. Okay? And at 5 degrees Celsius, the Henry's law is 61.2. The Henry's law constants. The Henry's law constant will change. Okay, the Henry's law constant will change. Depends on different gases and different temperatures. Okay, at 25 degrees Celsius, the Henry's law constant will be 40.2. Okay, so the solubilities will be calculated like this. Simple as that. Okay. So the symbol is this. So it's 12.8 and 8.4. Understand? So what does this tell us? This tells us as temperature increase, oxygen solubility increase. As temperature increase, oxygen solubility decrease. Okay, next slide show you the air streaming example for carbon dioxide removal. Okay, so in this example, we use air stream towel to remove dissolved carbon dioxide from groundwater. So after treatment, the towel lowers the carbon dioxide concentration. So based on the calculation, student take the calculation here. Okay, the concentration of carbon dioxide, equals the K times the partial pressure of carbon dioxide, right? So it's 10 to minus 1.3. 10 to minus 1.3 times the partial pressure of carbon dioxide, 10 to 3.7. And after convergence, then we got 0.44. The 0.44. Okay? But not finished yet. Okay? Not finished yet. Student take 2 years. If the towel lowers the level twice the equilibrium concentration. If the towel lowered the level twice the equilibrium concentration. So that means you need to times 2. Okay, you need times 2. So become 0.88 milligram per liter. Okay? The 0.44, this is equilibrium concentration. The 0.44 is the equilibrium concentration. But the question, not finished yet, okay? The question asks if the towel lowers the concentration to twice equilibrium, which means you need time 2. Understand? Okay, I tested this question in the previous exam. Lots of students write 0.44. Okay, lots of students write 0.44. They forgot to time 2. Okay, they forgot this sentence. If the towel lower the level twice the equilibrium concentration. So don't forget to time 2. Understand? Okay? So if you understand, please raise your hand. Okay? Last time, okay? About more than 50% write 0.44. And I asked TA to take off all the points. Yeah, because they are careless. To see the question, the real question is, if the towel lower the concentration twice the equilibrium. So don't forget the time 2. Okay? So the final concentration will be twice. Okay, next I would like to talk about absorption. It's absorption. Absorption. So absorption is good for the removal of dissolved substance from the solution. Normally we use activated. We use activated carbon. Because activated carbon has many tiny pores. So it has a very large surface area. Okay? The reason we use activated carbon because it has many tiny pores. So it has a very large surface area for absorption. Okay? The next slide shows you how to make the activated carbon. Okay? From different raw materials. Okay, you can use different materials. Okay, you can use different material to make different activated carbons. And the activated carbon is very good for the removal of heavy metals. Okay? The activated carbon can be used to remove heavy metals. Okay, not just that, even not just heavy metal, but also like odor, like VOC, volatile organic compound, and like solvent. Okay, so activated carbon can be used to remove not just heavy metal, but also odor, 臭味 right? 所以有些鞋垫用那种活性炭 right? Heavy metal, activated carbon can also be used to remove odor, volatile organic compound, and solvent. Okay, so this is the manufacture process of activated carbon from chrome. Okay, and let's look at this. Okay, so as I just mentioned, okay, the reason we use activated carbons for absorptions, right? Because it has many tiny pores, so it has very large surface area, and it can be classified based on the different size of pore. Okay, the micro pore regions refer to the pore size from 0 to 20 angstroms. Okay, angstrom. The symbol for angstrom is like this. This is 10 to negative 9 meters. 10. So this equals 0.1 nanometer. Okay, 1 angstrom equal 10 to the power of minus 10 meters, which means this equals 0.1 nanometers. And mesopores. The mesopore region referred to 200 to 500. Okay, 200 to 500 angstrom. So this is good for medium-sized molecules. Okay, so larger pore region is more than 500 angstroms. So this is gonna help the molecules enter the carbon structure. Okay? So this slide tells you different processes. Different processes help capture different pollutant slices. Understand? Different processes help capture different pollutant sizes. Okay. Besides that, we can also immobilize some functional group. We can also immobilize some functional group on the pole. Okay? So those functional groups will help to absorb. The reason we immobilize those functional groups on the surface of the pole, because it helps. It helps absorption more easily. Okay, so we can build some. We can immobilize some. For example, like hydrophobic. Okay, we can use hydrophobics or hydrophilics. Understand? So we can increase some absorbabilities by changing. We can increase some absorbability by changing different functional groups. Okay? So this slide tells us functional groups also matters. Functional group also matters. Okay? Some functional group can increase absorption. For example, like the polar group may reduce absorption because they prefer staying in water, which means hydrophilic, because they are hydrophilic. Okay? So by adjusting, by modifying the surface, the functional group on the surface of the pore, you may reduce or increase absorption. Okay, for example, the polar group, if you put some functional polar groups, it may reduce the absorption because the polar groups prefer staying in water, which means they are hydrophilic. So after you use those adiabatic carbon, you don't need to throw them away, right? You might also reactivate. Okay, you can recover. Okay, you can recover those adiabatic carbon. Okay, next slide. I would like to talk about the ion exchange. Ion exchange. So, ion exchange, or the electrodialysis, is good for the removal of ions from solution using resins. Okay, using resins. Okay, so I know most of you do not have test tube, so I just attached the test tube. So we might read over this. Okay, so ion exchange is good for removal of the ion from the solution using the resins. So resins, okay, the resin usually in the form of small beads. Okay, those resins usually in the form of small beads. Okay, which contains charge, 带电的 charge functional group. Okay, so we use some charge functional group. Okay, we use some charge functional group for the ion exchange. Okay, so some basic. Okay, for example, like this. Okay, so some basic idea. Okay, of ion exchange. There are two kinds of ion exchange. One is cation exchange. Cation exchange. The cation exchange is used to remove. The cation exchange is used to remove positive ions. Such as magnesium, such as lead, those heavy metals. Okay? So the idea is we have a solid with M. Okay? So, sorry, with H. And those are heavy metals we want to remove, right? So the reason we call exchange, right? So these two will exchange. So it becomes solid N plus. Okay? And this solid is resin. So the metal ion N plus will stick to the resins. And hydrogen ions, proton, will be released into the water. So this is number one, cation exchange. Okay? Number two is anion exchange. Of course, anion exchange is used to remove negative ions. For example, like chlorine ions. For example, like sulfate. Right? So this time, the resin should be attached to hydroxide group. Okay? And exchange with anions. So the anion will stick to the resins, and the hydroxide ion will be released. Okay? So two types of ion exchange resins. One is cation exchange. The other is anion exchange. Okay? And normally, student, take a look at this slide. Normally, we use sulfurous. Normally, we use sulfurous as functional group for cation exchange. Okay? Okay, normally we use sulfurous. Okay. Student, it will be like this. Okay, it will be like this. Okay. Normally we use sulfurous function as a cation exchanger, the function group for cation exchangers. Okay. And we use NR3 plus. Okay. We use this for anion exchangers. For anion exchangers. Okay? So these two are good for cation exchanger, and this one is good for anion exchanger. Okay, I mentioned here, right? It should be like this. Student, it should be like this. Okay, it should be like this. Do you understand? Okay? Everyone understand? This is what I mentioned here. Okay? So what we have? Okay. So I have some more you can read over. So okay, next week I will still continue to talk about the landfills. The landfill for Harvest West. It will be a little bit different from those municipal west, the southwest. Okay? So I gotta finish this up. And please don't forget to download the chapter 10 noise pollution 2. Okay? There are some calculation problems that you need to practice. Okay? And also the chapter 12, Harvest Managements, Harvest West Management 1. Okay? There are some fundamental facts. For Harvest West. We will go over very soon next week. Okay? But that's for today. Okay? Thank you so much for coming. Students, don't leave. Give me one more second. Okay, give me 1 second. I will not take attendance. Okay. Students, please have seats. Students, please have seat. Please see the blackboard here. So, the final exam will cover chapter 0. Okay, chapter 1, chapter 2. Okay, after that, chapter 9 from textbook. Okay, chapter 0 and chapter 1, that's background. Okay, you might not find 1 and 2. It's background, you might not find the textbook. Chapter 9 from textbook. Chapter 11. Chapter 10. And also chapter 12. Okay? The final exam will cover all this PowerPoint slide on Moodles. Besides that, I will not test. Okay, I will not test beside those chapters. So any questions? It's gonna be open book. It's gonna be open book. But you cannot bring any electronic device. So no iPads. No iPads. Only paper-based documents. Okay, only paper-based document. You can bring any paper-based document. Understand? No electronic device. But remember to bring calculator. We're gonna have calculation problem. Okay? Bring calculator. 要带计算机。Okay, that's for today.